Okay, this problem we are doing could be considered a distance or a trip problem. And we're going to go ahead and read it first, and then we'll learn how we're going to set it up. So John and Eleanor drove a total of 777 miles in 13.2 hours. John drove the first part of the trip and averaged 55 miles per hour. Eleanor drove the remainder of the trip and averaged 65 miles per hour. For what length of time did Eleanor drive? I'm going to set this up how you've done it in science class. Hopefully you can recognize that this problem is talking about distance and speed and time. So I'm going to use the formula that you have talked about quite a bit in science, which is distance equals rate times time. I would make a table to organize my data, and again, as with every word problem, if you have a different way to solve it, that is fine. As long as we get the same answer, we're good to go. So I'm going to show you how to set it up using a table. So I'm going to say in my table that the formula distance equals rate times time. And I'm going to see which of these variables they give us. Okay, so I'm going to fill in what I know about John and Eleanor. I know that together they drove 777 miles. So maybe I actually should also have a column for total, huh? Does that make more sense? So let's put a column down here for total. Total distance, total time, all that good stuff. And you won't always need a column for total, but after reading it again, that tells me that's what I need, right? So they drove a total of 777 miles. So that would be distance. I'm going to put 777 here. So I've used this number. In 13.2 hours. That'd be time. John drove the first part of the trip and averaged 55 miles per hour. So that would be John's rate, right? So he's going 55. Eleanor drove the remainder of the trip and averaged 65. So we also know her rate, 65. For what length of time did Eleanor drive? I don't know Eleanor's time. This is really important because they're asking for Eleanor, so I'm going to make Eleanor be our x, so that when we eventually solve for x, I have my answer and I don't have to do anything to it. So if Eleanor is x, what is the other parts? I got to fill in John's distance. Eleanor's distance I can do, right? Doesn't distance equal rate times time? So if I take 65 times x, Eleanor's distance would be 65x. That makes sense, right? So if I figure out John's time, I would also be able to find out his distance, just like I did for Eleanor. Here's John's time. The best way for me to explain this to you is for us to step away from the problem for a second. So I want you to think, right now, I'm going to tell you that my two children, they had to clean the basement. And it took them 3 hours. 3 hours to clean the basement, but they didn't do it together. My son cleaned the basement first, and he was really lollygagging. So he took an hour. And he said that he was done with his part. So he was, or I should say he was going fast. Okay, he took an hour to clean the basement. And together it took my kids 3 hours to clean the basement. So can you tell me how long it took my daughter to clean the basement if it took my son an hour and it took them together 3 hours? 2 hours, right? I mean, that kind of makes sense in your head, doesn't it? So now let's think about what you did there. If I said it took 3 hours total for my kids to clean the basement, and my son did it in 1 hour, how many hours did my daughter do it in? You just did what in your head? You took 3 minus 1, right? 3 minus 1, and you got, okay, that's 2. It took her 2 hours to clean it. That's the leftover. That's what you have in this problem. We're given a total right here. Well, it took 13.2 hours to do this drive. We don't know how long it took Eleanor, but if I just take Eleanor's or the total time minus Eleanor's time, I would get John's. Just like if you didn't know Ethan's time and you just said, oh, 3 minus x equals Bryn's time, you would have been able to figure out 2 eventually when you solve for x. So you take the total minus the part. 13.2 minus x. Total minus the part gives you the other part. That will work every time when you're given a total. So then for John, his is a little more complicated for his distance, but he's 55 times the quantity, 13.2 minus x. So now take a look at that table, and if you have questions on it, jot them down, and we can go through that tomorrow too. But that's how I would set that up. So now, when I'm actually going to solve this and solve for something, since they drove a total distance of 777 miles, I know that if I go ahead and add how far John drove plus how far Eleanor drove, it should equal the total distance, shouldn't it? The two parts make the whole, just like with time. So my equation would be 55 times the quantity, 13.2 minus x, so John's time, or distance, excuse me, plus Eleanor's distance, 65x. That should equal their total distance of 777 miles. And from here, it's just a solving the equation problem. So I'm going to distribute my 55, and I would get 55 times 13.2. I'm going to cheat and use my calculator, so I'm a little faster than doing it by hand. I would get 726 minus 55x plus 65x equals 777. So then I'm going to combine like terms on the left side. I would get 10x when I take that negative 55x plus 65 minus 726 from both sides. So I have 10x equals 51. Hopefully you can see all that. And then when I divide both sides by 10, I get x to be 5.1. Now, what does x represent again? Look up on my table. X is Eleanor's time. Isn't that what they're asking for? So I can say Eleanor drove for 5.1 hours. Now there are times when we're going to have you convert that to hours and minutes, but for right now we'll leave that, and we don't need to, we'll just leave it in decimal form because I know that's how your objectives do it, and I want to keep that consistent with those. If you wanted to find John's time, you could now substitute 5.1 in for x, and you would have John's time, which if you do that, it does end up being 8.1 hours, and then you can check all your work if you'd like.